about how you can select or modify a map projection based on how you want to use it. So maps can be sometimes shown in the geographic coordinate systems, but remember, latitude and longitude are measurements of angle. So this doesn't really make sense that we would space all of these the same. It does result in nice squares of equal dimensions of latitude and longitude, but there is a lot of distortion associated with this. For example, Antarctica is big, but it's not really bigger than Africa or some of the other continents shown here. So we want to choose an appropriate projection, and usually we keep these things in mind. We want to try to preserve the area, distance, shape, or direction, because it's not possible to preserve all of those on a map projection. So distortion is inevitable, but we can choose some of these projections in order to try to eliminate or control some of the distortion that's occurring on a map. So for example, with the cylindrical projection, we can preserve direction on this map so that a constant bearing would appear as a straight line, and it also preserves the shape. So even though the size of, once again, Greenland might be much larger than it really is, the shape of the coastline is exactly how it would appear on a globe. With a conic or azimuthal projection, we can preserve distance, and sometimes we can also preserve the area on these projections. So both the equidistant map projection and equal area map projections can be made with a conic. And sometimes we choose a conformal map projection, such as this one here, which could be a conformal if it's that type of map projection, or a compromise projection, something that doesn't really preserve any of these things, but still kind of looks good for a general purpose map, just kind of to show where we are in the world. So let's talk about some of these specific map projections. This is a universal transverse Mercator. The transverse indicates that the cylinder is laying on its side, and then the cylinder is touching the globe along one line, which would run right down the middle of this purple area here, which is called zone 16. So there's 60 of these. If we take this cylinder and we rotate it around the axis of the Earth, every 6 degrees we would get another UTM zone. So we get 60 of these zones running around the world, and these are really good map projections because they're good at minimizing distortion, especially if things run in a north-south direction. So zone 16 is shown on a map here, and the central meridian would run right down the middle of zone 16, and because this is a tangent case, that would be the only line along which there is no distortion. Another thing that comes up as far as map projections often is the state plane coordinate system. So the state plane coordinate system is not one particular type of map projection, but it uses many different map projections to try to minimize distortion within a state or within a portion of a state. So some states, some of the smaller states like Vermont and New Hampshire have only one state plane coordinate system, and even Montana only has one, even though it's a big state. In Oregon, there are two. There's a north and a south one. And in general, the ones where the orientation of these is from east to west, those are typically used Lambert conic conformal map projections, which are good for minimizing distortion at mid-latitudes, either above or below the equator. So the United States is really good for this. Lambert conic conformal fits well for us. And then there's kind of the north-south oriented ones, which typically use a transverse Mercator. So it's not the UTM, but it's a transverse Mercator that's specifically designed for these particular portions of these particular states. They're all designed to minimize distortion within a particular area, and that's what we would choose to use if we're using the state plane coordinate system. But once we have a coordinate system, we can customize that coordinate system if we want to. For example, if we look at the UTM zones and Oregon is not centered in between or directly in one of these UTM zones. It's kind of between these two UTM zones here. And similarly, if we wanted to make a map for all of Oregon, we have a Oregon North state plane coordinate system and an Oregon South state plane coordinate system. But if we wanted to, we could adapt either one of these map projections so that it accounted better for the entire state of Oregon in order to minimize the distortion over the entire state, as opposed to this one, which only minimizes the distortion either in the northern portion of the state, or this one